Hey, it's Miss Phelps, and tonight we're going to be talking about tessellations. Tessellations is actually a really fun concept to learn about, and it has some ideas that some people don't even realize are there. So let's go ahead and get started. Alright, okay, so just so I'm going to tell you up front, there's quite a bit of notes, and I'm sorry for that. I did try to keep it kind of limited, but I can only do so much with each topic. So here we go. Alright. A tessellation or tiling is formed when a shape undergoes an isometric transformation in a way that completely fills a plane in a symmetrical way without overlapping or leaving gaps. Okay, now that's a whole lot of information in one sentence, so let me just kind of break it apart a little bit. Alright, so you've got a tessellation and it's going to undergo isometric transformations. Remember, those are transformations that keep their shape and size. So basically you're either doing a translation, a reflection, or a rotation on them. Dilations don't count on this one. Alright, and basically you just lay it out and you piece it together, and you cannot have any overlapping or any gaps. So it's kind of like putting a puzzle together, but it's the same figure just turned different ways. Alright, the measures of the angles that meet at each vertex must add up to 360 degrees. And let me show you some examples and tell you what that kind of looks like. Okay, so here's three really nice examples of tessellations. And what I mean by that is where they make a vertex, like on this one, it has to add up to 360 degrees. So you know this, all of these, this half on the top equals 180, and then down here this half equals 180. So all together they make 360 where that point where the vertex is. And it's going to be the same way on these as well. This little spot here is going to be 90 degrees, and then this one is going to be 180, and then this piece over here is 90. And it's exactly the same with these, okay? So you've got a piece that's 90 right there in the corner, and then all the way around the rest of that is going to be 270. Okay, so that's just some information for you. Alright, let's keep going. Okay, when using congruent or regular polygons, the interior measure of each angle will need to be a factor of 360 degrees. That means it divides evenly with no remainder. Okay, remember, a regular polygon has all the same angles, the angles are the same, and the side lengths are the same, okay? And a factor is like 2 times 3 equals 6. Well, 2 and 3 are your factors. They make up that number. Alright, then it goes on to say the only regular polygons that meet the requirements are the equilateral triangle, a square, and a regular hexagon. So these are the only three that you can actually use to tessellate with. Alright, oh, and again, remember, regular polygons are closed-sided figures. Okay, a polygon, remember, is a closed-sided figure with straight sides. And then what makes it regular is that they have equal angles and equal side lengths. Alright, and that's actually the notes. It wasn't quite as many as I was expecting, but it was plenty, I'm sure. So I hope you have a great evening, and I'll see you in class tomorrow. Thanks, and make good choices.